to another Cloudonaut Plus video that I created for you this week. And yes, we have renamed our subscription model. It was called Cloudonaut Crew in the beginning, and now we switched to Cloudonaut Plus, so don't be confused. So that was just based on feedback that we received from lots of people that Crew is a little bit misleading, so we changed the name, but the content stays the same, so there's nothing to worry about for you. So this week, I'm presenting you a new service that is generally available since roughly 1 month. And the service is called Amazon Timestream. It offers a time series database in a serverless fashion, which means we don't have to provision anything up front. And the pricing model is purely based on usage. So there's no hourly cost associated to Amazon Timestream. You only pay for what you use, which means how much data you insert, how much data you store, and how much data you process. I've written a blog post about the topic where I unbox Amazon Timestream for you, which basically means you get a basic overview of how the service works, the benefits, and also some very easy, or a good use case where you can use it. And I use stock data as an example. I also recorded a podcast with Andreas about the same topic. So if you're interested in the very in the tutorial beginner kind of style thing, so if you want to know what Timestream actually is, I recommend that you check out the blog post as well. I will just quickly summarize it here in the video, and then we will look into a specific use case, and I show you some code, how do you ingest data into the database, and also how you query the database. But before we get started with Amazon Timestream, I want to ask you for a favor. Next week, we plan to have the first Ask Me Anything session, which basically means that you can send us questions and we answer them. So for example, we are looking for questions regarding, so this is my use case, which option would you pick? So this is my architecture, what do you think, how can it be improved? Or also more general questions, what do you think about this AWS feature, or how would you solve this problem? So if you have any question that is somehow related to AWS, feel free to send it to us. You can use several channels. You can send us an email, hello@cloudonaut.io. So that's a good way of getting in touch with us. You can get in touch with us on Twitter. And you will see my Twitter handle here in the video. You can also send me an email directly to michael@cloudonaut.io if you wish, so only I can read it. You can also post in the community, in the Cloudonaut community under this video. And just let us know what your question is so that we have a couple of questions up front before we do the live Ask Me Anything session. We will also record the session, so if you don't have time to attend at the specific time, there's no problem. You can get access to the recording afterwards. So feel free to send us your questions. We're really looking forward to the first Ask Me Anything question with all of you. And now it's really time to dive into Amazon Timestream. So I already mentioned it. It's a time series database, which means the data it is very good at handling is data where you have a timestamp and some measures associated to this timestamp. For example, a sensor reading usually is a time series data. So for a particular time, you get a sensor measurement. Also, stock prices are a good example. So that's what I have chosen here. And so those are, I think, the typical 2 examples that you will find about time series data. So whenever time is the most important piece of your data model, then time series databases are a good fit. This is also very handy in answering queries like, show me all the data from this time to this time. So that's where time series databases are very good at. They're also very good at aggregating those raw data points into, for example, 1 minute windows, 10-minute windows, 1 day windows, and things like this, and then calculate aggregations on top of that. So that's a time series database, and it is super cool that we now have access to such a thing on AWS, because it wasn't really a solved problem before. So there were a couple of workarounds. So people used DynamoDB for it. You could use Elasticsearch for it. Some people also used Redshift for it. But in the end, this was a missing feature or missing service. And that's why AWS released Timestream during re:Event last year, and now it is generally available. one thing that you have to keep in mind that the regional availability is not very good at the moment. So you will find Timestream only in the US regions and in Ireland. So if you're using any other region, then you have to wait a little bit because Timestream is not available in all the regions at the moment. So what I'm going to show you here today in this video is how you can import stock data into Timestream. So that's the first challenge, getting data into the database. And the second challenge is how can you analyze it? So we will answer questions such as show me the Amazon stock price over the last 30 minutes on a 1 minute granularity and show me the minimum and maximum for each minute, for example. So this is a typical question that we are going to ask the system. And this is very handy, for example, if you have to draw a stock price chart. So before we really can start, there are a couple of things that you need to get started. And the first thing that I'm going to use, I use a data provider that is free for personal usage in a restricted way. And the website is called finhub.io. So here you can register, and what you get is an API key. And with this API key, you can connect to their API, which is WebSocket based, and then you can get the data stream of stock data, for example. So that's just an example. If you want to work with any other data source, that's fine. This is just my example data provider here. So there are other data providers out there that you could use as well. So the first precondition is that if you want to replicate this, what I do here, so go to finhub.io and create a free account and get your API key. The next precondition is that I'm going to use Node.js for the implementation. So if you haven't installed Node.js yet on your machine, then feel free to install Node. I used version 12, but a newer version should work as well. So the next thing that needs to be done is you have to install some dependencies. And dependencies in Node.js are declared in a file called package.json. And you will find all those files together with the video on our community page. So there you can download it. I have exactly two dependencies. The first dependency is the AWS SDK, and I use the AWS SDK to interact with Timestream to ingest data into the time series database. And the second dependency is basically providing me WebSocket functionality. So this lets me connect to the WebSocket of FinHub.io. So it's not a very complicated API. You basically connect to the WebSocket and authenticate, and then you subscribe to stock ticker or symbols. So that's why I don't have a specific SDK for their API. So I just use the raw WebSocket module. Okay, so those are the two preconditions. So to install all the dependencies, what you do is you run npm install in the folder where the package.json is located, and then Node or the npm will automatically download the dependencies into the Node modules folder. And then you are fine. The next thing that you have to do is you have to create a Timestream database, and I show you how this works. So I will switch into one of the US regions where I haven't used Timestream before, and let me go to the create database button. So the first thing that you do is you create a database. So that's kind of the collection of everything. You select that you want to create a standard database, not a sample database. And I call my database US stocks. You can call this whatever you like. Keep in mind, if you use special characters, like for example dashes, periods and underscores, the queries get a little bit harder. So the first time I created the database, I used US-stocks. But then whenever you write a query, you have to put US stocks in quotes. So I now create a database without this special character because then the queries will be a little bit easier. But feel free to do or choose other names. And I will use the default AWS key. So I don't select anything special here. And then I just create my database. So that's the first thing that needs to be created, the database. And now you can create tables within the database. And I create a table, and my table will be called trades. So this is where I specify where I store the stock trades. So a trade is something that happens when a buyer and a seller come together on an exchange and agree on a price and a size, and then a trade happens. So that's basically when stocks are exchanged. So the buyer receives stocks, the seller gives stocks to the buyer. And this is called a trade. So that's the first thing that you have to do. But now we have to specify two more configuration settings. And the first is called the memory store retention. To understand what this actually means, we have to go a little bit into details into how Timestream works. In Timestream, your data lives in two different areas. Data is always ingested into the in-memory area. So this is the first place where your data lives. It is called in-memory area, but this doesn't mean that your data is not stored in a durable way here. It is still stored in a durable way, but it lives in memory. So making queries to this data is super fast because it is in memory. So what you can configure here is now that after a certain amount of time, and I will choose 1 day, this data rolls into the next area, which is called the magnetic store area. So this is where data actually lives on disks. And this is then a little bit slower to query, but it is much cheaper to store the data. So depending on your data volume, you might want have a larger or smaller in-memory area. And the magnetic store retention rate here is basically defining how long you want to keep the data. So in my demo example here, I want to keep the data for 10 days, but in the real world, I probably don't want to remove traits after 10 days. So maybe I will keep them for 100 years, or the maximum value here is actually 200 years. So you can keep data for quite some time, but keep in mind, you pay for the storage that you use. Okay, so that's my table. You can basically choose whatever you want here. It will not make this example, it will not make it unusable. So you can use this example with whatever data retention configuration that you can think of. So let's create the table. So nothing special here. One thing to understand is that there was no need to create a schema in the table. And that's cool because Timestream will figure out the schema on its own when we ingest our data. So the only thing that the table knows is the name and the retention policy. And that's it. Everything else will be managed completely by Timestream, which I find very handy. So now I have shown you to create the table. Now let's look into how you ingest how you ingest data into your database. And we are going to look at my Node.js code here. So two things that I do is first I get the dependencies. So that's the Node way of importing something basically. And I create the Timestream write client. And that's one thing to keep in mind. Timestream has two APIs, one for ingesting data, which is the write API, and one for querying the data, which is a query API. So those APIs are different and you need different clients for that. And then I open the WebSocket connection. And the way this works is that you connect to this websocket.finhub.io endpoint, and you specify a query parameter where you push your token into the system. So this is how the authentication works. And I have the token as an environment variable, so that's a kind of good way to ingest this into this program when we execute it. Okay, so the next thing, and I will show you the code at the bottom, is once the WebSocket connection is established, we receive a open event. So that's signaling that the WebSocket is now established and we can send data on the WebSocket. And I send 3 JSON objects over the wire, and I subscribe to 3 different symbols. And a symbol is basically a stock. And I subscribe to the Amazon stock, I subscribe to the Apple stock, and I subscribe to the Microsoft stock. And as soon as you subscribe, you will receive messages. And this is what the next event handler is about. So here we listen on the message event and we receive data packages. And the first thing that we do is we parse that string into an actual object. And it is serialized in JSON. So that's why we use the JSON parse method to deserialize it. And then I check if this is actually a trait. So there's a type field. And if this is a trait, the naive implementation would just directly ingest this into Timestream. The problem is that that's very likely not going to work because in this scenario, we don't really know the rate at which we receive data. So it could be that there are lots of messages coming in at the very same point in time, and we could have problems to actually push them into Timestream. And Timestream also really likes if we push data into the system in bulks. And that's actually how the API looks like. So they have a bulk ingest API. So we can ingest multiple data points at the same time using the API. And this is much more efficient than ingesting each and every data point into the system. So that's why I buffer all the incoming data first. So I have buffer is just an array. I just add this element to an array. And then I check if the buffer is longer than 50 elements. I flush the buffer in the background, which means that the system is going to work on this while new data is arriving. And on top of this, what I have here is I also specify that every 250 milliseconds I also flush my buffer, because otherwise I might have to wait longer than I wish until data becomes available in Timestream. Because, for example, if there's not a lot of trades going on in the system, I would have to wait for 50 trades for maybe a couple of seconds. And then this timer would kick in and will just every 250 milliseconds make sure that the buffer is flushed into Timestream. So let's look at the flushing background code. So what does it do? And there's actually one thing that I want to highlight here. So the first thing is that you cannot ingest a record in the same time series. And for us, a time series is defined by the symbol of the stock at the same timestamp. So that's not possible. So if, for example, the Apple stock has two trades that happen at exactly the same time, and exactly the same time is then most likely because we only get data, for example, with FinHub at a microsecond precision. So it is very likely that trades happen at exactly the same microsecond for the Apple stock. So that's a scenario that will happen. So we have to deal with that because we cannot ingest two different trades for the same stock, which is Apple, at the same time into Timestream. It's not going to work. You will receive an error. So what I do is, I know that my incoming data is in milliseconds, and what I do is I push data to Timestream in microseconds. And basically what I do is I keep a microsecond offset. So whenever I see a trade at the same time in milliseconds for a specific stock, I will increase the microsecond offset by 1, and I will ingest a trade into the system using microsecond precision. So in most cases, this will be just zeros. But if trades happen at the same millisecond timestamp, then we will see microseconds like 1, 2, 3, 4, 5, 6, 7, and so on and so forth. And this has one limitation. The limitation is that this only works if less than 1,000 trades happen at exactly the same time for a stock. And because I only have like the biggest offset I can add is 999. So that's a problem with my approach, but I think that is still like in practice, it has shown that this is not happening often. At least I haven't observed it so far. So I think that's fine. The next approach would be to ingest into Timestream with nanosecond precision, and then you have like lots of possibilities for trades happening at exactly the same microsecond timestamp. But keep this in mind, the timestamp is unique within a time series, and the time series is defined by what we call dimensions. And I have a single dimension when I push something into Timestream, and this is the symbol. So that's Apple, Microsoft, or Amazon. So this is what the time series identifies. And then you can report so-called measures. And we have two measures here because a trade has a price, and a trade also has what is called a size. So that's why I submit two measures. But those measures are submitted at exactly the same time. And that's going to work because they are two different measures. And the same time series, but two different measures, works at the same timestamp. So that's no problem. And as you can see here, I have to specify the types of all my data that I ingest. So for example, I define a symbol is a varchar, so that's basically a string. I also specify that my size is a big integer. I also specify that time is in microseconds and my price is a double. And very likely a lot of people will complain because you shouldn't store financial like currencies in a double because there will be problems with precisions. But that's actually the only supported data type at the moment that could store such value. So you have to be a little bit careful when working with those numbers, but that's just something that you have to keep in mind. And this is really a problem that I was faced with when I was working in finance a couple of years ago. So there are financial instruments that are priced at very strange increments. For example, a fraction of 64 or a fraction of 32. And with those things, it could get a little bit messy. But this is just something that we have to accept at the moment because we don't have a better type at the moment. I mean, you probably could use a big int and then just make sure that you always multiply by a certain number, for example, 1 million or 1,000. And so that could also be a workaround. But in my case, I just use doubles. Okay, so we prepared the data and then we call the write records API. And this is just you specify the database, you specify the table where this data belongs to, and you specify the records, and then we send it over to AWS and we hope that it works. The SDK will retry if things go wrong. So for example, if we are throttled because the system scales up, the SDK should deal with that. But if something goes wrong, there is no good error handling here. We will just lose the data. And that's something that we have to somehow deal with. So the code, for example, could handle it a little bit better and buffer longer, but at a certain amount of time, you will run out of memory because you cannot buffer forever on the client, like on the importer side. So that's a problem to keep in mind as well. So that's not really 100% bulletproof code here, but it already deals with timestamp deduplication. It does not yet deal very good with errors that are not resolved by retries of the SDK. But this gets very complicated because we have to deal with the limited memory of the importer as well. Okay, so that's it. Now we know how we can actually insert data into Timestream. Now the big question is how we can get data out of Timestream. And this is where we will write some queries. Switch to the query editor. So you have multiple options to send queries. So we will use the graphical way here, but there's actually an API where you send the same string as a query and you get back the result. So that's pretty handy also to integrate into your applications. So we select the database here on the left side. I have only one database, so that's not a big deal. And the first question that I have that I want to be answered is I want for the Amazon share over the last 30 minutes, I want to have on a per minute interval, I want to see the min and the maximum price of the share. So that's my first question. So let me switch to the region where I actually ingest data to, and that's the correct region here. And this is also the query. So let me go into the details here. So I will increase this a little bit to make it easier for you to read it. So the first thing that we do is we group the data. So this is basically aggregate, or this make sure that we are looking at 1 minute intervals. So I create bins of data and the size the size of the bin is 1 minute. So this is basically fulfilling the 1 minute granularity requirement of the question. I also say that I only want to see data where the time is not like is 30 minutes ago or newer. And I say I only want to look at the price measure and I only want to look at the symbol Amazon. So that's my work clause to make sure that I only get prices for Amazon. This is our table name. US stocks is the database name and trades is the table name. And now we go into the aggregations. So this here is just returning us the time, like the time bin that we are working with. So to make it a little bit easier to understand the output. Then I get the minimum of the measures and I get the maximum of the measures. And what is a little bit counterintuitive is that you always have to specify the type here. So that's a little bit like maybe not so super user friendly, but this is how it works. So if we're dealing with prices, we define this as a double. So we have to specify double here as well. Okay. I also, at the end, I order by bin time to make sure that we get a nice table. So let me run this query here. Oh, okay, there's something wrong. Let me see. Okay, so what you get now is that the minimum price and the maximum price for every minute. So that was the minute like 39, minute 40, minute 41. And you always get minimum and maximum prices of the Amazon share. So that's it. So we would expect exactly 30 elements here in this table. if we have data for every minute, which is not guaranteed because the exchange just emits data whenever it likes, but because Amazon is a share that is traded quite frequently, we will get actually a data for each minute. So that's fine. Okay, so let's extend this, this query a little bit. And now we work with two different symbols. So we work with two different measures. We are not only interested in the price, we are now also interested in the size. And this is where it gets a little bit more complicated. So let me paste in the query here and then I'm going to explain it to you. So what changed? First, in the work clause, I'm now not only looking at the price measure, I also look at the size measure. So that's the first thing that changed. And now it gets even more, I think, counterintuitive. So instead of having like direct access to all the prices and all the sizes, what I do is I have to use such a case statement where I say when the measure is a price, then please return it, otherwise return null. And then I use the average function over this data, and the average function just ignores all the nulls, and that's why I get the average of all the prices. And I do the same for the size. So I have a statement where I say only if the measurement is the size, return the value, otherwise null, and then I sum all of this up, and nulls are just ignored when summing up. So I'm not sure. So I think this is a little bit like lots of characters to type to basically get access to some data, but that's how it is. Okay, so what's wrong here? Invalid at line 1. Let me just copy and paste this over once again. It actually looks quite good. Okay, now it works. So this seems to be a little bit, so something seems to be a little bit buggy with the UI today. I was running into issues earlier this morning as well. Okay, but what we now get is we get the average price and the sum of the sizes of each for each minute over the last 30 minutes for the Amazon stock. So as you can see here, the size definitely varies. So that could be one, for example, indication of something of interest for some scripts or for some graphs. So what's another question that we might have? And now it gets more complicated because now we ask a question that does not involve a single symbol. Now we work with multiple symbols. So now I'm going to look not only at two different measures, price and size, I now also look at two different symbols, Amazon and Microsoft. And the way this works basically is again the same. So we now have actually 4 case statements. So the first time we get the prices of Amazon, then we get the sizes of Amazon, then we get the prices of Microsoft, and then we get the sizes of Microsoft. And then we return all of that in our result set. Okay, I don't know why this is not really working here. So let me just, I mean, that's usually not working with a computer, do the same thing again, but for the Timestream UI, it seems to help. Okay, so again, it's working now. So that's very strange. So I think that's just a problem with the UI. So what does we get here for every minute? And this is not ordered by bind time. So this will look a little bit better. Okay, so now we have a nice order of things. So what we have now is that we see for every minute, we see the Amazon prices and the Microsoft prices. And as you can see, there are times where we don't have Amazon prices because, for example, there was no Amazon share traded at that time, but a Microsoft share was traded. And that's totally fine because, I mean, if there's nothing, no trade was happening during that time, we also don't have a price. So that is the expected outcome. Okay. I hope you like this kind of deep dive into how you can ingest and how you can query data with Timestream. There are lots of other options to ingest data and to actually work with the data in Timestream. So for example, many AWS services have integration with Timestream. So for example, the IoT service can directly ingest into Timestream, so you don't need to write that code on your own. And also for the analysis part, so for example, you can connect Grafana to Timestream, so then you get a graphical like a graphical tool to make queries against the system. So there are a couple of options. So if you're interested in that, check out the blog post. So I listed a couple of them there. So that's also a good ways to interact with the system. Okay, I hope you liked my demo here. If you have any questions or feedback, then feel free to either send me an email, so I will show my email address here in the video, or directly comment on our community.cloudonaut.io site, where we also post this video. So thank you very much for watching, and see you next week. Don't forget to submit your questions for our Ask Me Anything session. Thank you very much. Bye.